talking about parallel grippers today. Okay, so what is a parallel gripper? Basically, it's typically used for pick up and place operations or similar repetitive tasks. It's used best when objects have specific geometry, such that it can be held equal pressure on both sides from two or more points, basically. Gripping pressure can be changed depending on the needs of the object and stuff like that. And typically, a combination of gripper size, material, and supplied air pressure dictates the minimum and maximum gripping pressure. Okay, so why is it called a parallel gripper? Basically, it's called a parallel gripper because it applies pressure evenly between 2 points on both sides, right? And the gripper can have more than 2 gripping arms, basically, and it can have integrated sensors to determine object size to center over the object and close evenly and parallel, basically. Okay, so you might recognize this. This is actually something similar to what we have in our classrooms, and here you can see the 2 arms that retract and close to pick the object up. And on the arms itself, they have the two holes. These are actually like extension holes where you can add or remove stuff. You can actually add add stuff to that, basically. And we have a little clip of our machine working, basically.
So as you'll see here, the gripper actually picks up the unit by clamping down on it, then lifting back up. You'll see here in a second. It will open back up and release the product. Same thing. Once it reaches the product, it clamps down evenly, parallel, and then releases evenly and parallel.
And this one actually is censoring it to determine the color of the material, the type of material. Alright, so pneumatic parallel grippers benefits and uses. Basically, they do repetitive simple tasks, basically. Elimination of human error or interface through induction of oils and particulates that are hazardous to electronics or fine manufacturing. So we know that our hands and stuff, they have oils in them, and you can't touch electronics basically. One more thing that I forgot to add was that the humans get tired working continuously. These machines, they don't get tired, so they can work endlessly as long as you take care of them. So 24/7 if you wanted to, basically.
With very little air. And also the actuators can be quite fast and efficient, also allowing for a certain amount of kind of forgiveness as it pressures down on the object. So imagine as if you were going to catch a ball, you were going to kind of catch it as if you didn't want it to make a hard impact. The same is possible with pneumatic parallel grippers. So you'll see here, these are the ones that we're familiar with in our class. These are 2-armed parallel grippers. This will be in the open position, and this is in the closed position. With pneumatics, how it works is when the air is applied, a piston gets driven, and it gets driven in the upwards position. The upwards position actually pulls the 2 arms right here in a tapered fashion up and away, so they actually get opened up and out. Then when it's closing, what it does is force the piston closed. It then forces these arms down and closed. In here, there's a tapered vein, so they follow up and down. So you also see here, this is our block diagram of a pneumatic system. Typically what's going on is a switch here, a pneumatic valve, is being pushed to one side, which allows one of the chambers to fill with air, forcing the piston that way, exhausting the other side. Then when it returns to the other side, it allows the exact inverse to happen, which fills this side, fills this side and exhausts this side, allowing the actuator to depress.
Okay, so drawbacks of using the machine, basically, if you're using pneumatic pressure, some disadvantages include not being able to control fine stoppage and the pressure under live conditions. So basically, if the machine's in motion, you can't really stop it, and you can't really control the amount of pressure that's being applied to the grippers, so you can't control the pressure being applied. And advantages include mechanical grippers include fine motor control during live operation, basically, and it allows for more detailed and interaction during the operation, so you can control the pressure being applied to the object, and when it stops and goes, basically.
And we'll see here an example of a mechanical parallel gripper. What it actually allows, it's using step-based gears, so you have quite a bit more finite control over where you're gripping and how much you're gripping. And as well, then, since it's electrically actuated, you have quite a bit more control over how much speed you're using. So just a couple examples, and then we have a question. So you can see a couple examples here. 6 degrees of freedom robotic arm with a parallel gripper on the end. Similar there and over here as well. Each one of these environments allowed for a very control, repetitive task with excluding the human interaction. So we're familiar with these from our class as well. Does anybody have a question?
Is there anything like that uses intelligence, or is it all just strictly pneumatics based?
So it absolutely can be intelligent. Integrated into the head of the gripper, you can put sensors, distance gauges,